Hello students, my name is Shivam and I am your math educator for grade 10. Alright, this is me. ये मेरा नाम है और ये मेरा काम है. But that's about me. I want to talk about you guys. I hope you guys are having fun preparing for your board exams because it's very important to enjoy what you're studying. And for maths, I'm going to take that responsibility on behalf of you guys. I'm going to make sure that you guys enjoy mathematics as much as I do teaching them. In this video, we will be talking about polynomials. Now, polynomials is a chapter that you have already studied in standard 9th. The first half of this video we will be doing some basic revision of those topics only, like the values of polynomial, zeros of polynomial, remainder and factor theorem and those things. In the second half, we will be looking at the division algorithm for polynomials, which is a very scoring topic and a number of questions arise from that topic. Alright, so let's start with today's session. First of all, let's see what is the basic general form of a polynomial. So an algebraic expression of this form, a0 plus a1x plus a2x square consisting of variables and constants, is the general form of a polynomial. But important thing, what is px? Px is the name given to a polynomial. Px is the name given to a polynomial in variable x. Qy will be a name given to polynomial in variable y. Small things, but these things matter. These are small things, but these things matter. So px is nothing but name given to the polynomial. N is called the degree of polynomial. Degree is the highest power of the variable present in the polynomial. Alright, one important thing regarding n should only be a natural number. What does that mean? The power of the variable in each term should only be a natural number. It can't be a negative integer, it can't be a fractional value, it can't be a decimal value. But the power can be 0. We have a special name for that kind of polynomials, constant polynomials. I hope you remember that. We will be talking about that also. So n should belong to the natural numbers, and for this polynomial to be of degree n, an should not be equal to 0. Coefficient of x to the power n, that is an, should not be equal to 0. Alright, what is the meaning of coefficient? All those terms multiplied with the variable are called its coefficient. For example, a1 is called the coefficient of x, a2 is called the coefficient of x square. Basic things, I'm just revising these things to you. Alright, x is called the variable of the polynomial. As I've already said, whatever is written inside this bracket will be the variable of the polynomial. If I write qt, then t will be the variable of the polynomial, and all those things which are different from t will be considered as constants. I have a question on this theory over here, so please focus over here, that x will be called the variable of the polynomial if the polynomial is written as px. If it's written as pt, then t is the variable. If it's written qy, then y is the variable, and anything apart from the variable will be considered as a constant. Alright, chalo. A0 is called the constant term. Constant term means that term which is independent of the variable. A0 over here is independent of the variable, so A0 is called the constant term. An is called the leading term, that is the coefficient of x to the power n is called the leading term. These are very basic things that you have already studied. Now let's study about the classification of polynomials. We can divide polynomials on the degree of a polynomial and on the basis of number of unlike terms in a polynomial. Like and unlike terms are the topics from standard 8, hai na? I mean 5 plus 3. You can write this as 8, but this is basically, these are two like terms only. 5 plus 3x, this will become one. These are two unlike terms. 5 is one term and 3x is another term. So 5 plus 3x, these are two unlike terms. Alright, so we can divide on the basis of number of unlike terms in a polynomial also, but on the basis of degree of a polynomial is more important. Alright, the first one that we have is a constant polynomial which is of degree 0. So the general form would be px equals to alpha, where alpha is some constant. That is, in a constant polynomial you won't be getting any variable. Fx equals to 5 is a constant polynomial. Fx equals to minus 7 is a constant polynomial. Second one would be 0 polynomial. Now the difference between 0 and constant polynomial is only this, that the degree of 0 polynomial is not defined. The degree of 0 polynomial is not defined. Degree of constant polynomial, we say it as 0, but the degree of 0 polynomial is not defined. Px equals to 0 is a 0 polynomial. Alright, linear polynomial of degree 1, quadratic degree 2, cubic degree 3, biquadratic degree 4, the next you will get quintic, and then so on. It doesn't matter, we don't have to study all those things. The general form of linear polynomial will be ax plus b, quadratic will be ax square plus bx plus c. So you just have to keep on adding the degree term to the previous one and you will get the general form of the new polynomial. All right. These are all from your standard 9, so I am not going to discuss these things in detail. I'm just giving you the basic idea. I'm just giving you the revision part of that. So on the basis of number of unlike terms, that is, if the polynomial contains only one term, it will be called a monomial. If it contains two terms, binomial, three terms, trinomial, then quadrinomial, and so on. It will go on like so. We don't have to worry much about the theory part. Maths is not theory. Maths involves problems like life. Okay, maths involve problems like life, and we have to learn through the problems. We have to go through the problems to find the solutions and all those things. So now we have taken the topic of finding the value of a polynomial. Right, the theory part is over. Now we will be dealing with problems mostly. How to find the value of a polynomial? If qx is equals to something, find the value of q2, q minus 1 and q0. First of all, q2 denotes value of qx at 2. Okay, q2 denotes value of qx at 2. And how do we find that value? We basically substitute the value 2 in place of x everywhere. We will write q2 is equals to 4 into 2 cube minus 3 into 2 squared plus 15 times 2 minus 2. So this is how we will get the value of q2 from over here. All right. If you calculate this, this will become 32 minus 12 plus 30 minus 2, which is 62, 50, 48. So the value of q2 is 48. All right. Similarly, q of minus 1 would mean we will substitute the value of x as minus 1 in the polynomial. So this becomes 4 into minus 1 cube minus. Always use brackets when you are dealing with negative numbers. 3 into minus 1 squared plus 15 times minus 1 minus 2. And you can calculate this to be minus 4, minus 3, minus 15, minus 2. This becomes minus 7, minus 22, minus 24. And the third one, you are asked the value of q0. So q0 will become, you will substitute the value of x as 0 everywhere. So the first term becomes 0, the second term becomes 0, the third term becomes 0, and the fourth term, which is the constant term, is minus 2. So the answer will be minus 2. Now this is an important point to note. Whenever you substitute the value of x as equals to 0, you will only get the constant term as the answer. Whatever was the constant term in the original polynomial, that will be the value of p0, q0. If px is your polynomial, p0 will be equals to the constant term. That is one thing that you can take out from this whole example. If px is your polynomial, then p0 will give you the constant term. All right. Of how to find the value of a polynomial, let me just generalize this for you. If we have the general polynomial px equals to a0 plus a1x plus a2x square and so on, if you want to find the value of this polynomial at x equals to alpha, so the first thing you will write is p alpha. P alpha denotes the value of polynomial px at alpha. All right, and you will substitute this value of x as alpha, a1 alpha plus a2 alpha square plus and so on. So this whole term will be some numerical value, will give you some constant value. So p alpha will come out to be some number. So the value of a polynomial at some number will be a some number. It won't be an expression. It won't be in the variables. It will be in the terms of constant only. All right. Now you can also think of finding the value as input and output. I mean, what you are doing basically over here is you are inputting the value of x as alpha. So alpha will be called your input. You are putting the value of x as alpha. So alpha will be called your input. All right. And what you are getting in return is p alpha. So p alpha will be called your output. All right. So P alpha will be called your output. Now why I am relating you in this way, input and output, is to understand the concept of zeros. Finding the zeros of a polynomial you all know, but what are the zeros of the polynomial? The input or the output? The zeros of a polynomial are the input variables. Okay, zeros of the polynomials are the input variables. Alright, but before going on to the zeros part, you have to solve this problem for me. As you can see, I have named the heading Learn with Problems, because whenever you are facing some problems, you need to learn from it. Alright, in maths and in life, both. Life is very much similar to maths. So what is the degree of pz is equals to this polynomial? What is the degree of pz equals to x to the power 5 plus 12x square minus 15x plus 1? Now if you answer 5, then that would mean that you haven't been paying attention from the first slide, because in the second slide itself I told you that in pz, z is the variable of the polynomial and the degree and all those things are defined for the variable of the polynomial. In the polynomial you don't see z over there, so anything other from z will be the constant for that polynomial. So this whole thing can be written as pz is equals to some constant k, where k is the value of this whole expression. X to the power 5 plus 12x square minus 15x plus 1 will be some constant value. It is not a variable terms over there. There are no variables present over here. So this is pz equals to k, and pz equals to k has the degree 0. This is a constant polynomial, so its degree is 0. Alright, this is a constant polynomial. Alright, I mean, you might find it very hard to relate, but this is a constant polynomial once you recognize the fact that pz is a polynomial in variable z. Important part, pz is a polynomial in variable z, pz is a polynomial in variable z. Okay, keep repeating this thing. Now let's take another example. For this expression to be a polynomial of degree greater than 3, for this expression to be a polynomial of degree greater than 3, n should be which among these? ये हैं आपके options, 1 2 3 4. Natural number, odd number, even number, whole number. N should be what? First of all, you have to see this expression 2y to the power n by 2 plus y cube plus 8y minus 7. This is your expression. Now in the question it asks first of all that this should be a polynomial. So what was the condition for an expression to be a polynomial? The power of the variables must be natural numbers. So n by 2 should be a natural number. N by 2 should be a natural number. Now for n by 2 to be a natural number, n cannot be an odd integer. N cannot be an odd integer. Why? Because if n is an odd integer, then n by 2 won't be giving you a natural number. So option B is automatically rejected. Now if n is any natural number, then will n by 2 be a natural number? The answer is no. Why? Take n equals to 1. Is 1 by 2 a natural number? No. So option A is automatically rejected. Now for n by 2 to be a natural number, again, is even number a sufficient criteria? I will say yes. For n by 2 to be a natural number, n is an even number is a sufficient criteria. But it also says to be of degree greater than 3. That means the value of n should be greater than 6. Only then the n by 2 term will be greater than 3. If n is greater than 6 and n is an even number, then only then n by 2 will be greater than 3. So that's why the answer is even number. And the whole number is also rejected, because if you put n equals to 0, 0 doesn't belong to natural number. Alright, I mean 0 by 2 will be 0 and 0 doesn't belong to natural number. So the answer to this question is C, even number. Alright, these were very basic questions. These were very basic questions. For the much complex one, I will be giving you time to solve these. I am just explaining some of the things that I have already told you. Now let's move on to the zeros of a polynomial, the input and output thing, what we were already discussing. In mathematics, we take problems to understand what the concept is. That is one of the beauty of mathematics. We take problems to understand the concept. For px equal to this, find the value of p of minus 2. As of now, I haven't talked about the term 0. For this polynomial, we have to find the value of p of minus 2. So we will substitute x equals to minus 2. 2 into minus 2 to the power 4 minus 2 cube plus 15 times minus 2 minus 10, and you do the calculation. 2 into minus 2 to the power 4 is 16, minus 2 cube is minus 8, 15 into minus 2 is minus 30, minus 10. So 2 into 16 is 32, plus 8, minus 30, minus 10, and by your knowledge of addition and subtraction, you can say that this will come out to be 0. Now what happened over here is you have input some value of the variable and the output you are getting as 0. The output you are getting is 0. So for those values of the variable for which the output becomes 0, the input variable will be called the 0 of the polynomial. We will say minus 2 is a 0 of this polynomial. Alright, I am repeating the statement again. For those values of the variable, the output becomes 0, then that value of the variable will be the 0 of the polynomial. In mathematical terms, we can say this as, if px be a polynomial, just a second, yeah, if px be a polynomial, and p of beta is equals to 0, if p of beta is equals to 0, then beta is a 0 of px. Okay, then beta is a 0 of px. Important point is, if p of beta is equals to 0, then beta is 0 of the polynomial, which is a very basic thing which you have already studied in standard 9th, and in standard 10th we will be using this concept in the factor theorem and division algorithm for polynomials, those topics. Alright. So as you all see that how did we find the 0 of a polynomial? We basically didn't find the 0 of the polynomial. We calculated the value of p of minus 2 and it came out to be 0. But from your class 9th experience, you all already know how to find zeros of a polynomial. Let me just revise that part again. First of all, let px be a polynomial of degree n. You equate that polynomial to 0. It's important to understand that the zeros of polynomial px and the solutions of px equals to 0, this equation, are the same thing. Zeros of polynomial px and the solutions of px equals to 0 are the same thing. Px equals to 0 is called the polynomial equation. For example, if I say that the zeros, find the zeros of the linear polynomial 2x plus 3. What we have to do is basically equate 2x plus 3 to 0, find the value of x equals to minus 3 by 2. So now this is the solution for this equation. This is also the 0 for the linear polynomial 2x plus 3. Alright. This is also the solution for linear polynomial 2x plus 3. Now, if you aren't able to look for the solutions easily, the second point I've written over here is observe for the solutions. Now, this might sound ridiculous and meaningless for you, but I'm telling you, observation is one of the most important tricks that you should be having while solving mathematical problems. I will give you an example. The statement written here is observe for possible solutions of x in px equal to 0. What does this mean? Let's say x square minus 4 is your polynomial. Okay, you equated it to 0. Now you have studied squares, square roots, cube roots. You would be knowing that x square minus 4, if x square minus 4 should be equal to 0, then the value of x can be either plus 2 or minus 2. है ना? I mean, this should come to you like a reflexive answer. You shouldn't have to solve for the values of x from this equation. All right. So this is even if you have to solve for this, if I take the polynomial x cube plus 3x square minus 2x. X cube plus 3x square minus 2x. Now, if I ask what is the 0 for this polynomial, won't you say that, sir, if I am putting x equals to 0, I am getting the polynomial overall to be equal to 0. So, x equals to 0 will be a solution, will be a 0 for this polynomial. And you didn't have to solve for it. You simply said that on putting x equals to 0, the whole polynomial will become 0. That is the definition of zeros of a polynomial. So, x equals to 0 will be a 0 for this polynomial. So, that's why I am saying that always go for the observational values first. Look at the polynomial, try to look for the solutions in your head only. Don't start with pen and copy immediately. All right. Observe for the possible solutions of px equals to 0. Now, if you are unable to find the solutions of x by observing, what you should do next is try to factorize the polynomials. Try to factorize the polynomials into linear factors. Like x minus a, x minus b, x minus c, these, if you are able to factorize the polynomials in terms of its linear factors, then each linear factor when equated to 0 will give you a 0 for the polynomials. What does this mean is that if for some polynomial you are able to factorize this as x minus 1 into x minus 2 into x minus 3. Let's say some polynomial was factorize into this product of x minus 1, x minus 2 and x minus 3. So the zeros for that polynomial, let's call that polynomial px. So the zeros for that polynomial will be x equals to 1, x equals to 2 and x equals to 3. How did we get these values of x? We equated each linear factor to 0. On equating each linear factor to 0, you will get the values of the x. And these values will be the 0 for the polynomial. I will explain this with an example. Let's take a quadratic polynomial x square minus 9x minus 20. Alright, x square minus 9x, let's say plus 20. And by your knowledge of middle term factorization, splitting the middle term, you know that this can be written as x square minus 4x minus 5x plus 20. I mean, I've done nothing new over. I have just split minus 9x in terms of minus 4x and minus 5x. Now, why I have split it in terms of minus 4 and minus 5 is because the product of minus 4 and minus 5 is plus 20. Alright, minus 9 can be split in n number of ways. It can be minus 8x minus x minus 10x plus x. These number of values are possible. But which value that we will choose is that the product of those split terms should be equal to 20 in this case. I am not going over the middle term factorization again. You all already know that from your previous classes. I just explained the idea. Alright. Chalo, so x square minus 4x minus 5x plus 20. Now you have to take common. X is common in the first two terms and minus 5 is common in the third and fourth term. And now in these two terms you will take x minus 4 as common, and what is left with you is x minus 5. So now I am able to factorize my polynomial px in terms of two linear factors. Now what I will do is equate these two linear factors to 0. Equate these two linear factors to 0. Okay, and now I will get from here the first after equating the factors we get x equals to 4, and from this factors we get x equals to 5. So x equals to 4 and 5 are the zeros of this polynomial px. So I hope you have understood how to find the zeros of a polynomial. Alright, now as you saw in the previous slide also, all the polynomials which don't have a constant term, all the polynomials which don't have a constant term will have one of their zeros as 0. All those polynomials which don't have a constant term, these kind of polynomials in which all the terms contain the variable, all the terms contain the variable, then on putting x equals to 0, the polynomial will become 0. So 0 is one of the zeros. 0 is one of the zeros of all those polynomials which do not contain the constant term. I hope you have understood this concept. Okay. So another very important concept over here. An n degree polynomial can have at most n real distinct zeros. Okay. Focus on each word over there. At most n distinct zeros. Okay. These are important thing over here. At most n real distinct zeros. I missed the part real. At most n real distinct zero. What does this statement mean? I will explain this also with the help of an example. You have a biquadratic polynomial here, x to the power 4 minus 10x cubed plus 35 and all those things. I know the zeros for this polynomial. You don't have to calculate. The zeros will, the factors will be x minus 1, x minus 2, x minus 3 and x minus 4. So this is a biquadratic polynomial of degree 4. all right, and this biquadratic polynomial of degree 4 can be factorized into at max 4 linear factors. This biquadratic polynomial can be factorized into at max 4 linear factors. It's not necessary that every time they will be factorized into linear factors. At times the factorization might not be possible, but if it is possible, then the maximum number of linear factors that you will be able to get will be equal to the degree of the polynomial, which is in this case 4. So this polynomial can be factorized as x minus 1, x minus 2, x minus 3, x minus 4, and for each linear factor you will get a 0 for this polynomial. For each linear factor you will get a 0 for this polynomial. So the maximum number of zeros for this biquadratic polynomial of degree 4 will be 4. Maximum number of real distinct zeros. Now why real and why distinct? We aren't talking about imaginary numbers over here, so let's keep the real part as it is. We won't be discussing much on that. Distinct is important because there are at times when the roots, when the zeros are repeated. All right, so even after repetition we count them as two different zeros. All right, even those things are out of syllabus as of now, but just keep this thing in mind that an n degree polynomial can have at most n real distinct zeros. And how do we get that is because an n degree polynomial can be factorized into at max n linear factors. Why only n linear factors? Suppose we were able to write this as x minus k for some other polynomial, for some value of k. Now if this biquadratic polynomial could have been factorized into 5 linear factors, then the degree of this expression, when multiplied all the terms, you will get x to the power 5 term, na? You will get a term which is of 5th degree. X into x square into x cube into x to the power 4 into x to the power 5. So if you are telling me that this is your main polynomial and it has been factorized into 5 linear factors, and if you open those brackets again, you are getting a polynomial of degree 5, but the original polynomial was of degree 4 only. So this is not possible. This is a contradiction. So that's why we say that an n degree polynomial can be factorized into max n linear factors. It may be less than that, but not more than that. All right, chalo, I hope you understood this point. I've got some examples over here. Ax square plus bx plus c. Similarly, ax square plus bx plus c can be split into 2 linear factors, px plus q and rx plus s, for real values of p, q, r and s. Okay, if there was another bracket involved, if there was another linear polynomial involved, then the degree of the resultant polynomial would have been 3, which is not exactly, which is in the original polynomial it's only 2. Okay, similarly with cubic we can explain this for every polynomial, but I'm not going to do those things again. I hope you have got the point over here that the n degree polynomial can have at most n real distinct zeros. Why? Because it can be split into at max n linear factors, not more than n. There may be less than n linear factors. Okay, chalo. Now let's start with the division of polynomials. So up till now there was more of theory and less of problems. From now you will be enjoying the problems. I'm pretty sure about it, because problems are fun to solve. You have to divide this by this. Very basic step. Class 9th mein you have done it. Let's do the simple division. How do we divide polynomials? The board doesn't want me to divide polynomials. Chalo. Write the polynomial over here. 2x to the power 5 plus x to the power 4 minus 6x plus 9. Acha, what is the term that is being divided called? This is from your class 4 and 5th. What is the term that is being divided called? That is being divided. It's called dividend. And what is the term that is dividing the dividend? It's called the divisor. And what do you get over here? Quotient. And what do you get over here? Remainder. Chalo, basic hai. So how to divide polynomials? Look at the highest power term in the divisor polynomial and look at the highest power term in the dividend polynomial. Okay, and you have to think of a term which on multiplication with x square over here will give you 2x to the power 5. You just have to focus on cancelling out the bigger power terms, all right, higher power terms. You have to cancel out higher power terms in each step. Okay, so x square on multiplication with 2x cube will give you 2x to the power 5. So you just have to focus about that only. So x square into 2x cube will give you 2x to the power 5. But along with that, you have to write on multiplication what you will get over here. You have to multiply 2x cube with minus 3x over here, and that will give you minus 6x to the power 4 and plus 2x cube. All right. So this is how you approach the division of polynomials. So x square into 2x cube is 2x to the power 5. Chalo. Now subtract this. On subtraction, 2x to the power 5 minus 2x to the power 5, this will get cancelled out. X to the power 4 minus 6x to the power 4 will give you 7x to the power 4. Achha, I will write it over here so that you guys don't get confused. This will give you 7x to the power 4. And minus, achha, there is no cubic term over there, so we will just place the cubic term over here, minus 2x cube. Why minus? Because this term is being subtracted. Chalo, let's put a bracket over here also. So now you guys won't be having any problem. 2x to the power 5 minus 2x to the power 5 cancelled out. X to the power 4 minus 6x to the power 4, 7x to the power 4. I mean, this is for class 10th. I don't have to teach you the basics of plus and minus over here, okay? So minus 2x cube and minus 6x plus 9. The rest you just have to carry it down. Now again focus on x square and 7x to the power 4. What you should multiply? You should multiply 7x square, because x square into 7x square will give you 7x to the power 4. So this becomes 7x to the power 4. This will become minus 21x cube. All right, and this will become 7x squared. Okay, now again 7 to the power 4 minus 7, this term gets cancelled again. Minus 2x cube minus 21x cube will give you 19x cube, and I am not going to explain how did we get 19x cube. Minus 7x square minus 6x plus 9. All right. Now x square into plus 19x will give you 19x cube. And 19 into 3 is 57 minus. So minus 57x square. The screen, I don't think the screen wants me to solve this question. Chalo, minus 57x square. All right. And 19 into 1 is 19 plus 19x. And now you do the subtraction again. This term gets cancelled out. Minus 7x square minus 57 will give you plus 50x square. Minus 6x minus 19x will give you minus 25x and plus 9. And now x square, 50x square, so we will multiply it with a 50. 50x square minus 150x plus 50. All right. So again, these terms get cancelled out, and minus 25x minus 150x will give you 125x minus 41. So this is the remainder. Why is this the remainder? Why am I calling this the remainder? Because just like in the divisions for numbers, you cannot divide now after the remainder gets smaller than the divisor. For example, if 37 is to be divided by 4, 9, 36, the remainder is 1. You don't proceed with the division again. Na? You leave the remainder 1 over here. Why? Because the remainder is now less than the divisor. Similarly, whenever you get the remainder, the degree of remainder polynomial lesser than the degree of the divisor polynomial, you stop the division over there. This is a linear polynomial. This is a quadratic polynomial. This is of degree 1. This is of degree 2. 1 is less than 2. So we stop the division over here. The degree of remainder polynomial will be less than the degree of divisor polynomials. That is one of the basis of the division algorithm for polynomials. So this is how we divide a polynomial. This is our remainder. This is the quotient, generally denoted by QX. Remainder generally denoted by RX. general denotation है, there is no compulsion that you have to use these symbols only. Chalo. So basically in these kind of questions we are asked to find the remainder. But do you think that we will perform the division every time to find out the remainder? No. And for that we use the remainder theorem for polynomials. You studied in the previous class. If you want to find the remainder of a polynomial upon division by a linear polynomial, in remainder theorem the important term is that the divisor polynomial should be a linear polynomial. Linear polynomial, the general form of a linear polynomial is ax plus b. All right. So in this question we are asked to find the remainder when this polynomial px is divided by a linear polynomial gx, which is x plus 2. So rather than doing the long division again, we are going to use the remainder theorem, which states that if a polynomial px is divided by a linear polynomial of the form x minus a, if a polynomial px is being divided by a linear polynomial of the form x minus a, then the remainder is pa. Class 9th. The remainder is pa. What does this mean over here is, to find the remainder in this case we just have to find the value of p minus 2. Why p minus 2? Because the general form of linear polynomial written over here in the remainder theorem, it's mentioned x minus a. So this is x plus 2, this will be written as x minus 2. So that's why the value of a for this question is minus 2. So p of minus a will be 3 into minus 2 to the power 4 minus 5 into minus 2 squared plus 3. All right. This will be the remainder in this case. I am going to talk about the remainder theorem in a little bit detail. In your class 9th books, now it was mentioned that let px be a polynomial of any degree n and gx be a linear polynomial of the form x minus a. All right. Now this might be a little bit confusing for some of you. Let gx be any linear polynomial, and the standard form of a linear polynomial is ax plus b. The standard form of a linear polynomial is ax plus b. So whenever px, a polynomial of degree n greater than equals to 1, is divided by gx of the form ax plus b, a linear polynomial of the form ax plus b, the remainder will be p of minus b by a. This is the remainder. Okay? When px is divided by gx of the form linear ax plus b. Okay, how did minus b by a get over here? You have to equate the linear polynomial ax plus b equals to 0 and find the value of x from over there. Okay, this is what we did over here also. Our polynomial is x plus 2. We equate x plus 2 equals to 0. We get x equals to minus 2, and then we put this value of x over here and find the remainder. All right, I hope you got this point. Okay, we have studied this for ax plus b. The remainder is p of minus b by a. All right. Now, the factor theorem for polynomials is just a continuation of remainder theorem. It states that if upon division the remainder comes out to be 0, then gx is a factor of px, which is common sense. 48 when divided by 12, remainder comes out to be 0. So we say now 12 is a factor of 48. Same thing. If upon division the remainder comes out to be 0, then gx is a factor of px, and the converse is also true. If gx is a factor of px, then the remainder will be 0. For example, if x plus 5 is a factor of this polynomial, find the value of k. So we have been given px is equals to 2x square minus kx minus 15. This is my px, and gx is given as x plus 5. So x plus 5 is a factor of px. If x plus 5 is a factor of px, then the remainder upon division should be 0. And what is the remainder? Remainder will be p of minus 5. Remainder will be p of minus 5, and this will come out to be 0. How did we get minus 5 over here? Again, x plus 5 equals to 0, so x equals to minus 5. You will use this value of x in polynomial. So p of minus 5 should be equal to 0. Now if p of minus 5 is equal to 0, then you substitute this value of x equals to minus 5. 2 into minus 5 squared minus k into minus 5 minus 15 equals to 0. And you calculate the value. Minus 5 squared is 25. 25 times 2 is 50. 50 plus 5k minus 15 is equals to 0. 5k is equals to minus 35. So the value of k will be equals to minus 7. Alright, so this is how you approach these kind of problems. If gx is a factor of px, then the remainder upon division will be 0. Now, this is not only true for linear polynomials. Let gx be any polynomial. If upon division, if px is divided by gx and the remainder comes out to be 0, then we will call gx as a factor of px. Alright? Chalo, I hope you got this point. If you want to copy this down, I mean, you can always press the pause button and copy it down. Let's move on to division algorithm for polynomials, which is nothing but we all already know. I will write the division algorithm for numbers first. Dividend is equals to divisor into quotient plus remainder. है ना? Basic elementary maths, class 4th, class 5. Dividend is equal to divisor into quotient plus remainder. Same thing hai, it's almost the same thing. It's just that over here you don't use the terms dividend, divisor, quotient. You use the terms dividend polynomial, divisor polynomial, quotient polynomial, and remainder polynomial. Only that is the difference. Now, it states that for two polynomials px and gx, there always exist two other polynomials qx and rx such that px is equal to gx into qx plus rx. Read this as dividend, divisor, quotient, remainder. Alright, two important conditions over here. Degree of rx should be less than degree of gx. Related to the number theorem, number theory, division algorithm for numbers, remainder is always less than the divisor. So, degree of remainder polynomial is always less than degree of divisor polynomial. Alright? Or, okay, I'm sorry, I pressed this one. Also, gx should not be equal to 0. I mean, you can't divide by a 0 na. So, the divisor polynomial should not be equal to 0. And when we say degree of remainder polynomial should be less than degree of divisor polynomial, we aren't talking about rx equals to 0. Why? Because rx equals to 0 doesn't have a degree na. The degree of 0 polynomial is not defined. So we mention the case that rx equals to 0 is also a possibility. The remainder can be 0. Okay. So this is the division algorithm for polynomials. This is very basic stuff, but the problems on this concept na are very interesting, and we will be looking at those problems right now. I love this heading, learn with problems. I mean, whenever you are facing a problem, you always try to learn from it. Okay, in maths, in life, hamesha. Divide x to the power 4 plus 5x cube minus this plus this by this and verify the division algorithm. So this is also a boring question, but it's important because syllabus mein hai. You have to divide this polynomial by this and verify the division algorithm. You have to approach via the long division method only. You write the polynomial x to the power 4 plus 5x cube minus 3x squared minus 7x plus 2, and you are dividing this whole lengthy polynomial by x square minus 4x plus 2. I have already taught how to divide. The first term that appears over here will be x square. So this becomes x to the power 4 minus 4x cube plus 2x squared. Then you perform the subtraction. So this gets cancelled out. And this becomes 9x cube minus 5x squared minus 7x plus 2. Then you focus on 9 and cube over here. So you multiply by 9x. So this becomes 9x cube. This becomes minus 36x squared. And this becomes 18x. Again you perform the subtraction, so these two terms gets cancelled out. Very boring, very monotonous steps these are, but you have to do because you have to get the marks also na. Chalo, so this becomes 31x square minus 25x plus 2, and to cancel out 31x square, you will multiply with the 31 over here. So this becomes 31x square minus 124x plus 62, and then you again do the subtraction. So this becomes 124 minus 125, which is 99x plus, no, minus 99x minus 60. Always avoid simple calculation errors, okay? Don't solve the questions in a very easy manner like I was doing. Don't, because they will give you calculation mistakes and those will take away marks for free. Chalo, so this was the division. This is your remainder, this is your quotient. It stays there, verify the division algorithm. What do you mean by verify the division algorithm? Now you have to multiply the quotient. Multiply the quotient and the divisor and add the remainder to it, and you will be getting the final dividend polynomial as the answer. So that will be called the verification of division algorithm. I am not going to do that. I am not going to do that. Or should I? But I will have to erase. Yeah, I will have to erase this part. Chalo, let's do that. Let's do that also. Hana, you all also please do it with me because it's getting very boring for me for this part. All the calculations and all. I mean, the problems are nice, but the calculations are... Acha, what was the remainder? 99x minus 60. 99x minus 60. Chalo, what is the divisor polynomial? X square minus 4x plus 2. Gx. What is the quotient? X square plus 9x plus 31. Qx plus remainder 99x minus 60. Okay? Open the brackets. X to the power 4 plus 9x cube plus 31x square minus 4x cube minus 36x square minus 124x plus 2x squared plus 18x plus 62 plus 99x minus 60. Okay? If there are any calculation mistakes, please ping me. So we got the first term x to the power 4. Now look for the cubic terms. 9x cube minus 4x cube is 5x cube. And we don't have any cubic terms. So we get plus 5x cube. Now look for the quadratic terms. 31x square minus 36x square is minus 5x square. Minus 5 plus 2 is minus 3x square. And we don't have any other quadratic term, so this is minus 3x square. Alright, now the linear term, the x term, minus 124x plus 18x. Minus 124 plus 18. Chalo, we also have a plus 19 over here. So 99 plus 18 will give you 117. So this is 117x plus 117x. This is minus 124x. So this will give you minus 7x. Alright. Plus 117x minus 124x is minus 7x. And now the constant term. What is the constant term? 62 minus 60, which is plus 2. So as you can see, that magic has happened over here. This is the same dividend polynomial. Okay, now let's move on to a better level of question. All right, find all the zeros of 2x to the power 4 plus 5x cube minus x square minus 6x if two of its zeros are 1 and minus 2. All right, I'm writing down the polynomial with a green ink, which I have to write with white ink. Okay, so I'm changing it to white ink. Yeah. So px is given b as 2x to the power 4 plus 5x cube minus x square minus 6x. And now can you guys observe something over here? I told you about the observation technique before. Always look at the polynomial before starting writing all of these. The polynomial over here doesn't have a constant term in it. So one of its zeros will be 0. One of the zeros will be 0. You are asked to find all the zeros of a biquadratic polynomial. So a biquadratic polynomial can have at most 4 distinct zeros. Two of which are already given, 1 and minus 2. So 1 and minus 2 are already the zeros of this polynomial that is provided to us in the question, and 1 0 by observation we have found out to be 0 itself. So now how many zeros do you have to find? Only one is left, because of the 4 zeros you already have the 3 zeros. Now important part, if 0, 1 and minus 2 are zeros of this polynomial, then can I say that x minus 0, x minus 1 and x minus minus 2 are factors of this polynomial? We have already discussed this part, that if alpha, beta, gamma are the zeros of a polynomial, then x minus alpha, x minus beta, x minus gamma are the factors of the polynomial. So x minus 0, x minus 1, x minus minus 2 are the factors of this polynomial. Their multiplication would also be a factor of this polynomial. है ना? So x minus 0 into x minus 1 into x minus minus 2 is also a factor of this polynomial, which can be further simplified as x into x minus 1 into x plus 2, and this can be further simplified as x into x square plus 2x minus 2, which is nothing but x into x square plus x minus 2, and this can be x cube plus x square minus 2x. So we have finally found out that after doing all these multiplications, that x cube plus x square minus 2x is a factor of our polynomial px. Now if we have a factor polynomial and the main polynomial is px, then upon division shouldn't the remainder be the 0? Shouldn't remainder be 0? It will be 0. But what will we get out of division over here? We will get the quotient. The quotient will also be a factor, na? Again, numbers. 50 is divided by 10. The quotient comes out to be 5 and the remainder comes out to be 0. So if the remainder is coming out to be 0, isn't the quotient also a factor of 50? Yes, it is. Yes, it is. So 2x to the power 4 plus 5x cube minus x squared minus 6x has a factor x cube plus x square minus 2x. Now if x cube plus x square minus 2x is a factor, then on dividing the remainder will be 0 and the quotient, whatever is the quotient, will be another factor of px. So let's perform the division. This will be 2x over here. This becomes 2x to the power 4 plus 2x cube minus 4x squared. Do the subtraction. This gets cancelled out. This becomes 3x cube plus 3x square minus 6x. And you can multiply with a 3 over here. So this becomes 3x square. Also this was cube. This is cube. So 3x cube plus 3x square minus 6x. And this whole comes out to be 0. So the remainder has come out to be 0. That means this is a factor, which we already knew that this is a factor. And the another factor is 2x plus 3. So if another factor is 2x plus 3, then we can say that x equals to 0, 1, minus 2 and minus 3 by 2 are the zeros of this polynomial px. I hope you understood the question how to solve this. The basic part over here is that if you are given two zeros, you take them in the factors form. For example, alpha and beta are your zeros. So x minus alpha and x minus beta will be your factors. Their multiplication will also be a factor of this polynomial. So you multiply it to get a quadratic or cubic polynomial depending upon the number of factors you have. And then you divide the original polynomial with the divisor polynomial to get the quotient. That quotient will be also a factor of this polynomial. From that quotient you will get the other zeros that are required. Alright, so I hope you understood the point. And again, I will emphasize on the importance of observation. This polynomial doesn't have a constant term in it, so x equals to 0 is a 0 of this polynomial. Okay, chalo. If you want to copy it down, I will again say pause the video and copy it down. How about this question? What must be added to this lengthy polynomial so that the resulting polynomial is exactly divisible by this? Okay, so this is another standard type of questions which generally are asked. What must be added to, what must be subtracted from some polynomial so that the resulting polynomial is actually divisible by this polynomial. Again, come back to the numbers. 28 divided by 3. I will write it in the algorithm form now. Won't perform the division every time. Chalo. 28 is equals to 3 into 7 plus 1. If I ask what must be subtracted from 28 so that the resultant is divisible by 3, common sense answer would be, sir, 1. Subtract 1 from 28, the resultant will be 27, and 27 is divisible by 3. है ना? So basically whenever you are asked at what must be subtracted from a polynomial, you have to subtract the remainder. You have to subtract the remainder. Now the question is what must be added to? The question over here says what must be added to, because the subtraction questions are very easy. Now what must be added to is also very easy. You just have to understand this concept, that if you are subtracting 28 minus 1, then it is divisible by 3. ठीक है? This is divisible by 3. If you add minus 1 na, even then this is divisible by 3. 28 minus 1 can also be written as 28 plus minus 1. So now what are you adding? In this case, in the first case, you were subtracting 1. In the second case, you are adding minus 1. Alright, so whenever you are asked what must be added to this polynomial, you just have to add the negative of the remainder. You just have to add the negative of the remainder. I hope you understood this point. Chalo, so the polynomial is 4x to the power 4 plus 2x cube minus 2x square plus x minus 1, and you have to divide it by x square plus 2x minus 3, and again I will change the pen. Chalo, perform the division. The division is a very easy steps for the 4x square. So this becomes 4x to the power 4 plus 8x cube minus 12x squared. Subtraction, cancelled out. Minus 6x cube plus 10x squared plus x minus 1 minus 6x minus 6x cube minus 12x squared plus 18x. Again subtraction, and this gets cancelled out. So this becomes 22x squared minus 17x minus 1. We will perform the division one more time, because even now the degree of the remainder isn't less than the degree of the divisor polynomial, but after this step it will be less. So we will terminate the division over there. This also gets cancelled out. Minus 17 minus 44 is 61x, and this is plus 65. So this is your remainder. So the question asks what must be added to this polynomial so that the resulting polynomial is actually divisible by this. So this is the remainder. If you subtract this from px, let's call this px. I'm just repeating those steps again. If you subtract rx from px, the resultant will be divisible by gx. But the question is not asking what must be subtracted, the question is asking what must be added. So you just have to write this as px. You are adding negative of remainder. So in this case, what is the negative of remainder? Minus 61x minus 65. So this will be your final answer. This term you have to add. this term you have to add in the polynomial so that the resultant is divisible by this polynomial. Chalo, let's move on to another question, a little bit advanced from the previous questions. This question involves finding out two unknowns. All right, have a read of this question. Find if the polynomial x to the power 4 minus 6x cube plus 16x square minus 25x plus 10 is a biquadratic polynomial, degree 4, is divided by a quadratic polynomial x square minus 2x plus k. The remainder comes out to be x plus a. So you have to find the values of k and a. So this question involves finding the values of two unknowns. We will simply start with doing what the question has already told us. The question has said that the remainder comes out to be x plus a. So we are going to find out the remainder, and then we are going to compare that remainder with the given remainder x plus a. Let's start with the division process. The polynomial is x to the power 4 minus 6x cube plus 16x squared minus 25x plus 10, and it is being divided by x square minus 2x plus k. All right, now you already know how to divide the polynomials. We start with an x square over here. X square multiplied by the x square will give you x to the power 4. The second term will be minus 2x cube and plus kx squared. Now we will do the subtraction part. So minus plus minus over here. All right, x to the power 4 gets cancelled out. Minus 6x cube minus 2x cube will give you minus 4x cube. 16 minus kx square, and the rest we just have to copy down. All right, now what will be the second term? Now we will look to cancel out the minus 4x cube term, so we will multiply with minus 4x only minus 4x, because x square into minus 4x will be minus 4x cube. So minus 4x cube is written over here, and minus 4x multiplied by minus 2 will give you plus 8x squared, and minus 4x multiplied by plus k will give you minus 4kx. All right, again the subtraction part, these two gets cancelled out, over here minus and over here plus. So 16 minus k minus 8 will give you 8 minus k x squared, minus 25 minus 4k will give you plus 4k minus 25x. I just rearrange the terms and written. You can write however way you want. Plus 10. Now again one more step for division, because even now there is a quadratic term present over here and we need to cancel out the quadratic term, because the degree of the remainder polynomial should be less than degree of divisor polynomial na. So now we will multiply it with 8 minus k. 8 minus k multiplied by x square will give you 8 minus k x squared, and this term multiplied with minus 2x will give you minus 2 times 8 minus k x, and this term multiplied with k will give you k times 8 minus k. All right, now again the subtraction, and yeah, so these terms again get cancelled out, and what you get is 4k minus 25 minus it will change to plus 2 times 8 minus k, and this whole thing is being multiplied with x, and the constant part is 10 minus k times 8 minus k. All right, so this is the remainder you are getting upon division. This is also the remainder that should be equal to x plus a, because the question is given the remainder is x plus a. So if the remainder is x plus a, then what should be this term? The coefficient of x in the remainder should be equal to 1, because only in that case the remainder will be x plus a. So now we will equate this whole term to equal to 1, and this is a. This whole term will be a. So to find the values of a, first we will have to find the value of k. Now to find the value of k, we will just equate the coefficient of x from over here. Achha, I need some more space over here, so I'm gonna write a little below. Yeah, or maybe I will change it to the next slide. Yeah, so 4k minus 25 plus 2 times 8 minus k. This was the coefficient of x, and this should be equal to 1. All right, now let's solve it. 4k minus 25 plus 16 minus 2k equals to 1. 4k minus 2k will give you 2k, minus 25 plus 16 will give you minus 9. This comes out to be 1. So 2k is equals to 10, or you can say the value of k comes out to be 5. So now that you have got the value of k equals to 5, you can put this value of k over here to find the value of a. What is the value of a? 10 minus k into 8 minus k. So 10 minus 5. 10 minus 5 into 8 minus 5. This is your value for a. So upon calculation you will find this has to be 8 minus 5 is 3, 5 into 3 is 15, so 10 minus 15 is minus 5. So the value of a is minus 5. So k is 5 and a is minus 5. These are your answers for this question. When a polynomial fx is divided by some linear polynomial, the remainder comes out to be 5, and when it is divided by x minus 2, the remainder is 7. Find the remainder when it is divided by x minus 1 into x minus 2. Now this question is kind of my favorite one for this chapter, because it involves almost all the concepts that we have studied till now. All right. When a polynomial fx, we don't know the polynomial, we have named it fx, it is divided by x minus 1, the remainder comes out to be 5. So there is a polynomial fx and it is being divided by x minus 1. So there will be some quotient, let's call it qx, or rather q1x, and the remainder comes out to be 5. Okay. Or you can simply put this statement as f1 equals to 5. है ना? By remainder theorem, you can simply put this whole statement as f1 equals to 5. Similarly, I will write for the second case, fx when divided by x minus 2, the remainder comes out to be 7, and the quotient is, let's say, q2x plus 7. All right, this statement can be written as f2 equals to 7. All right, let's call this equation 1. Let's call this equation 2. The question is asking that what will be the remainder when fx is divided by x minus 1 into x minus 2. Let's call that there will be some quotient and some remainder. So rx is my remainder and I have to find the value of rx. Now why did I say that this question involves all the concept of this chapter is because what will be rx? What should we suppose rx to be? We want to find the value of rx, na? So we represent the unknowns with our variables over here. The remainder polynomial, by division algorithm, we know that the degree of remainder polynomial is always less than the degree of divisor polynomial. In this case, the degree of divisor polynomial is 2. It's a quadratic polynomial. X minus 1 into x minus 2 is x square minus 3x plus 2. If you open the brackets and do the multiplication, the divisor polynomial is x square minus 3x plus 2. That means the degree of the divisor polynomial is 2. So that means my remainder polynomial can either be a linear or some constant. So remainder polynomial can either be linear or constant. So if the remainder polynomial is linear or constant, then what can I suppose it to be? Ax plus b. This is the general form of a linear polynomial, and it also covers the possibility of the remainder coming out to be constant, because if the remainder was a constant, then the value of a will come out to be 0 and we will be only left with b. So now I have to find the values of a and b for this case. Now how to approach this? I will again move on to the next slide to explain this. Chalo. We know that f1 is given to be 5. f2 is given to be 7, and I have to find the values of a and b over here. All right, I have to find the values of a and b over here. Now what is the use of these two information over here? We haven't made use of these informations yet in this question. Now we will do that. We will put x equals to 1 over here. So this equations become f1, and on putting x equals to 1, this whole term becomes 0, because 1 minus 1 is 0, 0 multiplied with anything will become 0. So this becomes 0 plus a times 1 plus b, and we know that the value of f1 is 5, so 5 is equals to a plus b. This is my third equation. All right. Similarly, we will again substitute the value of x equals to 2 in this equation. So that will give me f2 is equals to, again this whole term x minus 1, x minus 2, qx, this whole term will become 0. So this becomes 0 plus a times 2 plus b. And we know the value of f2 is given to us as 7. So 7 is equals to 2a plus b. And now these are simultaneous linear equations in two variables, the solution to which you know how to solve. We can simply subtract equation 3rd from equation 4th and we'll get the value of a. How? I'm doing it over here. You can simply do the equation 4 minus equation 3 part. 2a plus b minus a plus b. So we first subtract the left hand side from the left hand side and right hand side from the right hand side. So 7 minus 5 will give you 2. And 2a plus b minus a plus b. I will write it down for you guys. 2a plus b minus a plus b. And when you open the brackets, b gets cancelled out. So the value of 2 is equals to a. So the value of a comes out to be 2. And you substitute this value of a as 2 in any of the equations 3 or 4, then you will get the value of b as 3. So you get the values of a as 2 and b as 3. So the remainder will be ax plus b. We call the remainder as ax plus b. So the remainder will be 2x plus 3. So I hope you got how to solve these kind of questions. I mean, many of you confuse it that, sir, fx is not given, then how do we proceed with it? We don't have to find fx. We don't have to find fx. Whatever is given in the question is sufficient enough to find the values of the remainder over here. You let fx be fx and you use the values of f1 and f2 to find the values of a and b over here. All right. So in this video we have covered all the basis of the polynomials and the division algorithm for polynomials. I hope you enjoyed this session, and I hope that you practice problems based on these topics so that you get a more clear understanding of the concept. Thank you.